Today we're going to talk about sensory receptors and then neuronal circuits for processing of information. Okay, our objectives is to define uh, the receptors, sensory receptors. The sensory receptors are called sometimes transducers. Why transducers? Because they transduce, they convert whatever kind of energy they are sensitive to. يعني ممكن يكون mechanical energy, physical energy, photons, electrical into electrical energy. يعني what is going to reach the cerebral cortex up and to see that this is a sensation or not is electrical action potential. بس الستيمولاس ممكن تكون ميكانيكال، ممكن تكون كيميكال، ممكن تكون نوسيسبتورز زي بين. ايش اللي بيساوي ترانسديوسرز بتحول هاي الانرجي into electrical energy and then we will classify them. We will describe the potential that occurs at these receptors. We call it generator or receptor potential, and we will see what's its importance in coding for these sensations. And then we will list the types of somatic receptors in the skin, explain the mechanism of sensory coding. What do we mean by sensory coding? يعني هدول receptors or sensory system, how it determines the intensity of the stimulus, how it determines the location of the stimulus, and how it determines the type of the stimulus. يعني احنا بنحكي انه what reaches the cerebral cortex up there is electrical, is action potential. طب شو بيعرفوا الcerebral cortex انه هذه السنسيشن هي pain او هي temperature او هي pressure او هي touch. This is what we call it sensory coding. وايش بيعرفوا انه من وين جاي، من اليمين من الشمال من الايد من الرجل. And then we will talk about adaptation and the mechanism of adaptation and the types of sensory receptors in terms of adaptation. Some receptors they adapt fast, some receptors they adapt slowly. The one that they adapt fast we call them phasic receptors, and the one that are slowly adapting receptor we call them tonic receptor. Also, in the end, we will describe neuronal processing and its functional importance. You see here with what we do, we classify the receptors according to the modality. Modality, what do we mean by modality? Mean the type of sensation. لما تحكي mechanoreceptor modality يعني mechanical stimulation زي touch زي pressure زي vibration. These are mechanical deformation. أو تحكي thermoreceptors. So mechanoreceptors they detect deformation in terms of touch pressure. Thermoreceptor detect change in temperature, thermal in warm or cold. Nociceptors detect the pain which are due to tissue damage. And these are very important receptors. Electromagnetic photoreceptor detect light. The receptors are called rods or cones, العصيات والمخاريط. Chemoreceptors like taste, like smell, like CO2, like oxygen. These receptors they test changes in these substances. We can classify them according to the location. Exteroceptor. Exteroceptor they are located on the surface of the body. Sensitive arising from outside, located or at or near the surface, include receptor for touch, pressure, pain, temperature. That's a receptor that are found in the skin. Or enteroceptor. These receptors found inside our body, in the internal viscera. This sometimes we call them visceroreceptor. From viscera, monitor evaluative distinction of the viscera. يعني مثلا تحكي عن الintestines distended or some kind of contraction, pain from there. And the third type is called proprioceptor. Proprioceptor. They sense the change in position, monitor the degree of stretch. Sure position. Position معناته joint. Joint angulation بتتغير. Muscles, tendon. Some also touch receptors around the joint. So these are the two classifications. The first classification according to the modality, the second classification according to the location. Let's see, here are the receptors. As you see here, these are the receptors that are called free nerve endings, found just under the epidermis. Usually these might detect touch, might detect pain, might detect pressure. Expanded tip receptors. Expanded tip receptors, they are called Merkel's disc. Merkel's, according Merkel, he is the first one who described these things. Tactile hair receptors. So these are hair that are found around the hair shaft. This is the hair shaft. So these receptors are found here around the hair shaft, which means they are sensitive to movement of the hair. Pacinian corpuscle. Although Pacinian is the name of the scientists who describe them, but because it is so used, so Pacinian is used as if it is a name here of these corpuscles. These are like onion rings, زي حلقات البصل. وبالداخل هذا, this is the afferent neuron. And these are found deep in the dermis, موجود تحت بالأدمة. If they are found in the dermis, most probably they are sensitive to pressure. And because they are encapsulated, هون في كبسول حواليهم. If they are encapsulated, usually they are sensitive to rapid stimuli like vibration. And if they are encapsulated like Messinian corpuscles and Meissner corpuscles here, they are rapidly adapting receptor, corpuscular. These Meissner corpuscles, they are found in the epidermis, so they are sensitive to touch here. Krauss's corpuscles found in the dermis, they are sensitive to pressure. Ruffini end organ, they are found down in the dermis, sensitive to pressure. Golgi tendon apparatus. Golgi tendon, from its name, Golgi is the person who described them, and tendon, they are found in the tendon of the muscle. These receptors, they are sensitive to change in tension of the muscle, force, and the muscle spindle, it is found inside the muscles, and they are sensitive to change in the length of the muscle. So as you see, muscle spindle and Golgi tendon receptors, they are found in the muscle here, so they are sensitive to proprioceptor sensation, proprio, sense of position. Same here, this is what in the skin, how you see them. This is the free nerve endings. You see they are sensitive to pain and touch sometimes, and also pressure. This is the Meissner corpuscles found in the epidermis, sensitive to touch. These are Merkel's disc. Merkel's disc, as you see, this Merkel disc forming a dome here, dome. And sometimes this dome is called ego dome, RGGO. Ego, first person, the person who described them. This is Ruffini end organ found in the dermis, sensitive to pressure. This is Pacinian corpuscle found in the dermis. This is the hair end organ. So as you see, found around the hair shaft. So it is sensitive to movement of the hairs, here. Okay, these are the receptors. These are, of course, exteroceptors found in the. This is another picture for these receptors. This is the Meissner corpuscles, as you see, found here in the epidermis here. This is the Pacini-Messner corpuscle. This is the Pacinian corpuscle found down in the dermis, and this is Pacinian corpuscles. This is the Merkel disc, and as you see Merkel disc here, this is the Merkel disc. They form egodome. We will see its picture right away. And this is the Raffini end organs found in the dermis, sensitive to pressure. This is the hair end organ, hair shaft end organ. And this is the free nerve endings found in the epidermis, just below the epidermis. Okay. We don't ask you to remember its name. We're not going to ask to give you structures. This is the egodome. This is the Merkel disc under the epidermis, forming a dome here. And IgGO is the name of the person with this problem. Okay. Okay. These receptors, they are connected to afferent neurons. The free nerve endings are connected to A delta fiber and C fiber. They detect pressure, touch and pressure from the skin, and they detect pain and temperature. So as you see, since they are connecting to A delta and C, they are connected to the smallest myelinated fiber and unmyelinated. So their speed of transmission is slow. Messner corpuscles, Merkel's disc, Pacinian corpuscles, all of them, they are connected to A beta fiber, A beta, which is large myelinated fiber. As I said last time, since they are encapsulated here, corpuscles, they are rapidly adapting receptors. And rapidly adapting receptors, they are also sensitive to vibration. Sense of vibration يعني الشوكة الرنانة هاي تبعها بتكون on off يعني very rapid sensation. And they are found in non-hairy skin, glabrous skin, where fingertips and lips يعني مو موجودين بالأكزيلا مثلا. الأكزيلا is hairy. In other aspects, Merkel's disc, they are also connected to A beta fiber. Rapidly, they have two kinds of adaptation: rapid first, then slow. They detect the slow and detect steady state. We will talk about adaptation later on. But these Merkels, they are found in hairy, like the axilla, and glabrous and non-hairy skin. So they are found in both hairy and non-hairy skin. Hair end organ, of course, they are found around the hair shaft and detect movement over the body. Raffini end organs, they are found deep in the dermis. They detect pressure most of the time. If they are found around the joint, they detect joint movement. Pacinian corpuscles, they are rapidly adapting. As you see, they are corpuscles. They are sensitive to vibration, and they are connected to A beta fiber, and they detect pressure. Okay. Messner corpuscles, hair receptor, Pacinian and Raffini end organs, they transmit very fast signals, very fast, A beta fiber, with a speed of transmission between 30 to 70 meters per second. Free nerve endings, I mentioned the last slide, they transmit signals through A delta or C fiber, so their speed of transmission is slow. A delta between 5 and 30 meters per second, and C fiber between 0.5 and 2 meters. The more critical the sensation is, they are usually transmitted faster rate. Like fine touch, fine pressure. What do we mean fine? Fine, we mean well localized. Okay, well localized. These are the receptors. The receptor area here is of two types. The receptor area. The receptor area could be separate from the afferent neuron. As you see, this is the afferent neuron and this is the receptor. And in between them, there is a chemical connection, chemicals and neurotransmitters or something like that. Or the receptor area could be the terminal, the terminal part of the afferent neuron, as you see. So they are interconnected. Whether this or this, the mechanism of transduction, the mechanism of transmitting the signal is the same. But this receptor area here, whether this one it is the terminal part or it is separate from the afferent neuron, in both cases the receptor area is non-excitable. What do we mean by non-excitable? يعني at this area, at these areas here, we don't have action potential change. If we don't have action potential, it means at these areas we don't have voltage gated sodium channels. Okay. Why it is non-excitable؟ يعني هاي نعمة من نعم الله أو طريقة، يعني لو كانت excitable، افترض إنه كانت excitable. If it is excitable يعني if there is a stimulus here, أو here, well, the stimulus is here or there, and if the stimulus is weak, it does not reach the threshold. If it does not reach the threshold, it's not going to cause action potential. If it's not going to cause action potential, it's not going to transmit signals through the afferent neuron مثلا. So if it is stronger enough to just only changes the membrane potential on these receptor areas, that is just the threshold. If it is just the threshold, it will cause action potential هون, action potential على الريسبتور area. طيب إذا صار الأكشن potential, if this action potential is formed there, ممكن البوتنشال كم يوصل؟ plus 30. شيك potential, this is the membrane potential, ممكن يوصل plus 30 during action potential. Plus 30 is going to stimulate the afferent neuron, say with مثلا plus 30 stimulus ممكن تكون 1000 impulses per second in the afferent neuron هون. So the afferent neuron here, might transmit impulses, just sample 1000 impulse per second. طيب فرضا another stimulus which is stronger than the first, the second stimulus, stronger than the first that reaches, يعني stronger، أقوى من اللي وصلت للثريشولد. بما انها اقوى من اللي وصلت للثريشولد طبعا بدها توصل للثريشولد وتزيد. شو بده يساوي هون؟ اكشن بوتنشال. اكشن بوتنشال كم بده يوصل؟ بلس 30. سو اس اكشن بوتنشال بلس 30 شو بده يعمل هون؟ بده يعمل impulses 1000 impulse per minute per second. طيب السيستم how the system knows انه الامبلس الستيمولس الاولانيه اللي كانت just enough to reach the threshold weaker than the stimulus that is reaches the value above the threshold. لأنه اللي وصل هناك وصل 1000، لأنه this is the things أكثر من 1000 ما بوصل مثلا في الحالة هاي. إذا كان لأنه في الحالتين in the two cases وصلنا الممبرين بوتنشال بلس 30. فإذا بلس 30 بده يعمل نفس النمبر of stimuli of impulses. إذا ما بيعرف فرضا حالي زدنا الستيمولس، the stimulus was too strong. If this area is also excitable, it will cause action potential, it will reach plus 30. Plus 30 شو بده يعمل؟ It will cause impulses 1000. طيب, if it comes to the cerebral cortex 1000, this is the third time, fourth time. So the cerebral cortex, the system, not the cerebral, the system will not be able to differentiate between different strengths of the stimulus if this area is excitable. Okay. So نفترض هون the areas, this area is non-excitable. If this area is non-excitable, if you have a weak stimulus, this stimulus will cause a potential that is, say it is just the threshold. If it is just the threshold for this neuron, this neuron will transmit impulses. مثلا كان الأكشن potential كليات الأكشن potential 10 ملي سكند. إذا كان 10 ملي سكند أكشن potential والستيمولس وصلت الممبرين potential, يعني وصلت الممبرين potential هون due to opening of ligand gated channels وصلته لبلس minus 40. Say this is the threshold. The threshold is minus 40. وهون هذا just the threshold وصلته. إذا هذا الافferent neuron will transmit impulses. إذا طول الأكشن potential 1 ملي سكند, إذا بده it transmit impulses بيساوي 1000 على 10 بيساوي 100 impulse per second. شايف؟ شو الألف هي ال1 second. ال1 second هي 1000 ملي سكند. So 1 second is 1000 millisecond. 1000, each action potential is 10. 1000 over 10, 100. Okay. The next time we stimulate it with a stimulus stronger than the first. If it is stronger than the first, it will open more ligand gated channel. And the membrane potential here, بدل ما يكون minus 40, if the membrane potential, instead of being minus 40, it will be minus 30. If it is minus 30, it means it will stimulate this neuron here during the relative refractory period. إذا كان all the action potential is 10, during the relative it might be during every 8 milliseconds. Every 8 milliseconds we'll have a stimulus during the relative. طيب if they're during 8 معناته 1000 over 8 معناته صار الامبulse rate في هذا النيورون 125 impulse per second. If the cerebral cortex receives 125 this time, the cerebral cortex will interpret this, oh, this is a stronger stimulus, or the strength of the stimulus this time is stronger than the first. Now, if you have even stronger stimulus, it will change the membrane potential, بدل ما يكون minus 30. If it is just minus 30, this time it's zero potential. Zero now, it's very strong stimulus. It will stimulate this neuron during the relative refractory period of the action potential. It might be every 5 milliseconds. So 1000 over 5, this means it is 200 impulses per second. So the cerebral cortex will differentiate this as a stronger impulse, stronger stimulus than the first one. Now you will becoming stronger and stronger and stronger. The maximum you can reach is the absolute refractory period. فرضا كانت absolute refractory period is 2 milliseconds. If the absolute refractory period 2 milliseconds, I cannot exceed the absolute refractory period. So 1000 over 2 is 500 impulse per second. So the maximum rate of the impulses in this afferent neuron in that case is 500 impulses per second. Even if I have a stronger stimulus, I cannot exceed the absolute. In that case, what determines the maximum rate of impulses in the afferent neuron is the absolute refractory period. So the absolute refractory period is the limiting factor. It limits the maximum rate of impulses that might be transmitted through the afferent neuron. So here the receptor area, whether this area or this area, in both cases, is non-excitable. Why? To discriminate different intensities. Otherwise, it will not be able to differentiate strength of the impulse. Now, this is a receptor. This is a receptor area. When there is a stimulus here, when there is a stimulus here, and the stimulus, usually it will open ligand-gated, what we call it stimulus-gated channel. Stimulus-gated channel. And the stimulus-gated channel, how many stimulus-gated channels are open? It depends on the strength of the stimulus. The more sodium channels here, the more channels are opened, the more is the membrane potential becoming less negative, whatever. In this area, opening of stimulus-gated channel will change the membrane potential here. And change of the membrane potential here is called receptor potential. Receptor potential. Now, in this case, when the receptor area is the terminal part of the afferent neuron here, change in the membrane potential is called generator potential. Generators. But I use both of them interchangeably. I don't differentiate because there is no difference, but it's just a name. Here it is generator potential when the area is the terminal part of the receptor, and here is called potential when the receptor is separate. When the receptor is separate, بصير هون change in the membrane potential. مثلا صار depolarization. This depolarization causes release of these neurotransmitters or chemicals. These chemicals, they affect the afferent neuron and cause the afferent neuron to transmit impulses. Here, the change in the membrane potential here itself is direct. There is no membrane, there is no neurotransmitter directly cause change in the cause action potential or not. Depends on if the generator potential equals or less or more than the threshold. Okay. This is here. This is the receptor potential because the area is separate from the afferent neuron, and this is generator potential. Both of them is the same here. If there is a stimulus here, there is a stimulus. This is the stimulus. It will affect the receptor, and it will change the receptor membrane potential into it depends. If it is sodium channel, say, the stimulus opens stimulus-gated channel, and these channels are sodium. Sodium will enter, according to its electrochemical gradient. You remember when we described the equilibrium potential for sodium is plus 60, plus 61. So the sodium channels are open. Sodium tries to reach plus 61. It will never, of course, reach plus 61, because there are other ions involved. So the membrane potentials become less negative. This is called depolarization. And depolarization leads to a release of chemical messenger or neurotransmitter that affects the afferent neuron here and cause opening of voltage-gated sodium channel in this case. Because when you say voltage-gated, you mean action potential. When you call stimulus-gated or ligand-gated, you mean local potential. Now the same thing here. If there is a stimulus, and the stimulus opens stimulus-gated sodium channel, sodium will enter. It will change the membrane potential to a less negative value. This will stimulate the first part of the afferent neuron here. First part of the afferent neuron, like the axon hillock, if you remember from very first lectures. And here we have voltage-gated sodium channels. The voltage-gated sodium channels open, and you will have action potential here in the afferent neuron, like here in the afferent neuron. How many action potential, what we call it impulse rate or rate or discharge rate, depends on the local potential here, the local potential, the receptor or generator potential. The more less negative. يعني احنا بنحكي عن إشي تاني اسمه amplitude of the receptor potential. يعني الريسبتور بوتنشال إذا كان هيك، هاي الريسبتور بوتنشال، الامبليتيود هون، هاي الامبليتيود من هون سي سي كان ماينس 70 طلع لماينس 40 فرضا. الامبليتيود كام؟ 30 ميلي فولت. بس in other case كمان other case if the stimulus is stronger if the stimulus هون is stronger هيك كانت هيك the amplitude in this case كان من minus 70 لا minus 30 فرضا ميلي فولت. كم الامبليتيود في هاي الحالة؟ 40 ميلي فولت. هلا الامبليتيود إذا كان 40 ميلي فولت if the amplitude is 40 millivolt here it is stronger stimulus than the amplitude it is 30 millivolt. So this is what we mean the amplitude. The higher, the more the amplitude, the stronger the stimulus, the stronger the stimulus is. Okay. Okay. We will see that in the game. Then sensations characteristic of low of specific sensation. Now, these receptors, they are sensitive to one kind of energy. One kind of energy. يعني receptors for touch, they are sensitive to touch. Receptors for pressure, they are sensitive to pressure. Receptors for temperature, they are sensitive to temperature. Receptors for pain, they are sensitive to pain stimulus. And pain stimulus, in fact, is due to damage of tissue. So the sensation character, each sensory neuron that produces its normal to what we call it adequate stimulus. What is the adequate stimulus for the receptor? Adequate stimulus. The adequate stimulus for any receptor, this is qualitative. This is not quantitative. مش adequate مش كافي يعني. The adequate stimulus is that stimulus that is sensitive to. يعني touch receptor, their adequate stimulus is touch. Pain receptor, their adequate stimulus is pain. Thermal receptors, their adequate stimulus is change in temperature. So the adequate really requires the least amount. If pain receptor, it is highly sensitive to pain, but is it going to be stimulated by another kind of stimuli? Might be, but their threshold for the other kind of stimuli is very high. يعني pressure stimulus or touch stimulus, touch receptors. They are highly sensitive to touch. Are they going to be stimulated by pressure? Yes, maybe. But their threshold for pressure sensation is much higher than their threshold for touch. Now, regardless of how the sensory neuron is stimulated, sensory neuron مثلا attached to touch receptors. If this sensory neuron is attached to touch receptor, wherever you stimulate this neuron, is going to transmit the impulses to the cortex. The cortex will feel it as if it is touch. ما بتفرق. If you stimulate the receptor, if you stimulate the neuron, if you stimulate the CNS, if you stimulate the cerebral cortex area, this is going to be stimulated and you feel the same sensation. So regardless of how sensory neuron is stimulated, only one sensory modality, الموداليتي اللي هي حكيناها type of sensation, one modality. And this kind of law is called the specificity of the receptors. So the receptors are specific. Touch receptor, they are sensitive to touch. Pain receptor, they are sensitive to pain. Thermal receptor, they are sensitive to pain. Photons, light, they are sensitive to light. Chemicals, are they going to, or can they be stimulated by other kind? Yes, but their threshold for the other kind of sensations is very high. But whatever the kind of stimulus is, you're going to feel the same sensation. ما بتفرق. Sensation is specific. Allows brain to detect, perceive the stimulus accurately under normal condition. Now, each of the principal type of sensation, touch, pressure, is called modality of sensation. Again, this is type of sensation. We call it modality of sensation. Modality of sensation. So each modality, each receptor is very highly sensitive to its modality. Now, each receptor is responsive to one type of stimulus energy. This is the specificity, is the key property of receptor, underlines the most important coding for the one important for the coding mechanism. This is how the sensory system codes for the type. So the sensory system codes for the type or for the modality by the specificity of the receptor. This is what we're coding. Also, the other things is pathway. From these receptors to the cerebral cortex, say touch sensation, they have one pathway specific for them. There is another pathway, say, for pain. Pain sensation, they have another pathway. Pressure sensation, they have another neurons, another pathway. This specific pathway for this specific sensation is called labeled line principle. يعني كأنه every line, every neuron is specific for certain kinds of sensation. يعني تقول you have a way مثلا خط عمان الزرقاء. خط عمان الزرقاء من وين ما دخلته بوصلك مثلا. خط عمان جرش بتوديك على جرش. فنفس الشيء هذا الخط, this line is specific for this kind of sensation. This called will labeled كأنك you label it. بتسميه labeled line. So there are two ways by which the modality or the type of sensation is coded for. أول شيء the type, the specificity of the receptor. Second is the specific pathway or labeled line. How the sensation is perceived determined by the specific characteristic of the receptor and the central connections, the pathway, central connection, the specificity of the receptors and the central connection of the receptors is the pathway, okay? Receptor excitation. What is the mechanism of receptor excitation? Mechanical deformation. مثلا حكينا touch أو pressure. This mechanical deformation stretches the membrane and changes the permeability of the channel. Changes the permeability of the channel. If they are open, might be closed. If they close, might be open, whatever. Application of chemicals also might open channels. Change in temperature, since change in temperature will change the metabolic rate of the receptor area, it might also change the permeability of the channel. Electromagnetic radiation also changes the membrane characteristic, changes the permeability of the channel. In fact, that's why I changed it. It's not opening of the channel. Most of the stimuli, they open channels that are closed, like sodium channels, stimulus gated. They are not voltage gated. Voltage gated, when you say voltage gated, you talk about action potential. When you take stimulus gated, you talk about, or ligand gated, you talk about local potential, like what we were going to describe after a while. Receptor potential is a local potential. Why I said a change in the permeability. In the electromagnetic, in the photons, electromagnetic, يعني receptor for light, rods and coils, the sodium channel were open, and when the light comes, the sodium channel close. So this is why we said this is the only place where there is close the sodium channel rather than opening. That's why we said to just overcome the problem, we said closure of, so we said change in the permeability of the channel. Okay, this is the mechanism here. This is the receptor region. Any deformation here will change the permeability of the stimulus-gated channel, or the same thing like ligand-gated channel. If these channels are sodium, sodium will enter. This will change the membrane potential here. It will cause what we call it receptor potential or generator potential. It's not problem. This is the stimulus. This is here the stimulus, and this is the receptor potential. The receptor potential, if it reaches the threshold for this neuron, and this is the area is called receptor region. The first nodes of Ranvier where the action potential starts is called spike generating region, and the other is called conducting region. So if the receptor potential reaches the threshold, then it will transmit action potential in this afferent neuron. How many action potential in the afferent neuron depends on the receptor potential. إذا كان هون minus 70 ل plus minus 30 بده يكون less than the action potential that be transmitted إذا كان الستيمولس وصلته من minus 30 ل من minus 70 ل minus 20 or the 0. And you remember the local potential here. This is the local potential. The local potential is graded potential. يعني إذا كانت الستيمولس stronger بتوصله، إذا كانت بالبداية stimulus weak وصلته من if the stimulus weak and it's coming from minus 70 to minus 40. If the stimulus is stronger, it might reach it from minus 70 to minus 20. If it is stronger, minus 70 to 0. If it's stronger, minus 70 to plus 10, and so on. So the stronger the stimulus, the more the strength of the stimulus, the more is the amplitude of the action potential. في البداية كان من minus حكيناه من minus الامبليتيود كان from minus 70 to minus 40، بعدين كان from minus 40 to minus 30, minus 70 to 0, minus 70 to plus 10, and so on. So this is the way how it is. And the more the amplitude, the more the number of impulses, the more number of action potential in the afferent neuron. Why? Because it's going to stimulate the neuron during the relative refractory period. We're going to stimulate during the relative until we reach the absolute refractory period. When you reach the absolute refractory, whatever the strength of the stimulus is, you no way can exceed the absolute. So what limits the maximum rate of the afferent neuron is the absolute refractory period. The absolute refractory period, okay? Here the same thing. This is the receptor potential, opening of ligand-gated here, ligand-gated or stimulus-gated channel open. This will cause depolarization here, depolarized area. Depolarized, it means it's going to stimulate the neuron. It's the first action potential will occur in the first nodes of Ranvier. This is called spike generating region, and this is called conducting region. And this is action potential, and this is here local potential. This is local potential and is graded potential. Graded potential. As you see, the impulse is weak, but stronger, it might cause more and more potential on the afferent, on the receptor area. Receptor potential, the membrane potential of the receptor. This is called receptor. Excitation of the receptor results from change in this potential. When the receptor potential rises above the threshold, action potentials appear in the receptor is and the receptor is active. Action potential appear where? Appear in the afferent neuron. The greater the intensity of the stimulus, the greater the intensity of the stimulus, the greater the receptor potential. Our receptor potential, if it is weak, from minus 70 to minus 40. If it is stronger, from minus 70 to minus 30. If it's stronger, from minus 70 to 0. If it's stronger, minus 70 to plus 10. Much stronger, minus 70 to plus 30. This is maybe the maximum. So the greater the receptor potential, the greater the rate of action potential generating, because the greater the receptor potential, it means it's going to stimulate the neuron during the relative refractory period. حكينا بالبداية if the action potential is 10 millisecond وكانت the stimulus is just the threshold, معناته the number of impulses in that case is 100 impulses per second. If the stimulus is stronger, it might stimulate it during the relative. If with the relative يعني معناته ممكن it might be during every 8 milliseconds. Every 8 معناته the rate is 125. If it is even stronger, every 5. It means if it is every 5, it means 1000 or 200 and so on. Okay? Until you reach the absolute. If the absolute refractory period is 1 millisecond, معناته the rate is 1000 over 1. The maximum rate is 1000 impulses per second. Okay? So this is the generator potential or receptor potential. In response to stimulus, sensory nerve endings produce a local graded potential. Local graded potential, or can be summated. Potential changes called receptor potential or generator. It's analogous to EBSBs, exactly like the EBSBs. paradigm. On this is the stimulus in case one is weak. ما وصلت. It's not reaching the threshold. It's not going to cause any action potential. You're not going to feel it. Stimulus number 2 also, you are not going to feel it because it does not reach the threshold. What's the threshold? Stimulus number 3 is going to reach the threshold, is going to cause action potential in the efferent neuron. Stimulus 4, it is more than the threshold, and so on. So this is the action potential in the initial segment of the neuron اللي هي like هذا. If it reaches the threshold, you feel it. If it is more than the threshold here, this is going more and more action potential and so on. Okay? So more action potential. It depends here على amplitude. The more the amplitude, because if the amplitude is more, معناته the stimulus is stronger. This is the way. So if this is the stimulus, membrane potential can minus 70, minus 90, whatever. There is no way there is action potential unless you reach the threshold here. Okay? When you reach the threshold, there is action potential. See here, when the stimulus is, when the receptor potential is higher than the threshold and higher, the rate of action potential here is higher. The rate of action potential. So the more the amplitude اللي هون, the more is the rate of action potential. The rate of action potential. Okay. This is the stimulus strength. The more the strength of the stimulus, the more is the amplitude of the action potential, or of the receptor potential. The more is the amplitude. This is the receptor potential in real units. So here, as you see here, the more the stimulus strength كانت كتير تزيد. شو بيزيد الامبليتيود of the action of the receptor potential. The amplitude ضل يزيد بالاخير بضل stable. يعني وصلنا plus 30 هون. We cannot exceed maybe plus 30 millivolts. فايش صار almost plateau. شوف here in this curve there are two areas of sensitivity. This area here, this is the steep part of the curve, is the very high sensitivity area. يعني هون small change. شوف من 2 ل 3 قديش بيكون change in the amplitude from 2 to 3. نشيلهم ونحط واحد ثاني. From 2 to 3 قديش في change in the amplitude. There is too much change in the amplitude. If there is too much change in the amplitude يعني من 0 من 2 ل 3, if there is too much change in the impulse rate. This means any small change in the stimulus strength will cause too much change in the impulse rate. So the system will feel it as if stronger and stronger and stronger. تطلع هون changes from 4, look here, changes from 4 to 5. There is no much change in the amplitude here. If there is no much change in the amplitude, there is no much change in the impulse rate. If there is no change in the impulse rate too much different, the system will not be able to differentiate the difference between 4 and 5, but it is able to differentiate between 2 and 3 very much. So here, this area is less sensitivity area, and this area is high sensitivity area. The purpose of the sensory system is always to bring it to the high sensitivity area. يعني إذا كان وصل if the system reaches the low sensitivity area بتلاقي صار في عندنا feedback from the cortex back to the sensory system. It's called corticofugal pathway feedback. They will inhibit it and they will produce it, bring it to this area. Why to bring it to this area? To make it more sensitive and more sensitive. So this is the higher sensitivity. So as you see here, this is the more the strength, the more is the amplitude. The amplitude يعني بيكون زي ما شفنا هناك. Like what you have seen here. This is the amplitude. The more the strength, the more the amplitude. من هون the same here. You see this is weak impulse, number 1. Weak, stronger, بس ما وصل, it does not reach 3 and 4 and stronger. It means higher, the stronger, the more the amplitude. Now, the more the amplitude, here, the more the amplitude of the generator potential, the more the spike. The more the amplitude, the more the spike. Then the more the amplitude, the more the spikes. Number of spikes is more when the amplitude is more. Okay? Now here in the end you reach plateau لأنه احنا حكينا إنه ما بصير ما بضلش linear. You reach plateau ليش؟ لأنه reach هناك كانت ضلت plus 30 الامبليتيود. But here you reach plateau. You're not going to be linear all through. Okay? Okay. Thank you very much. شكرا كثير. We will meet you in the next lecture. Thank you.